that's an interesting story that I get to know from my seniors and mentors, that 10 years back, if we would visit this cluster by road, 10 kilometers before reaching the town, we would see sanitary ware waste just thrown on either side of the road. That much rejections we had as a cluster of industry. Now, of course, since past couple of years, the pollution control board has started getting stricter, so they can't throw away the waste outside their premise. So the town is pretty much cleaned out, but the whole waste is just being hoarded within the premises of these industries behind the walls.
Hi, this is Himang. Welcome to another episode of Innovation, Sports and Life. Today I have with me Shashak Nimkar. Shashank is the founder of Earth Tatva, a very interesting startup which works on reducing mineral from natural resources by making products from recycled ceramics. Their impact is so great that they have a reduction of mining by more than 60%. He also contributes to circular design, which is what we'll get into, as a visiting faculty at educational institutes and policy and systems design. I love the motto which he follows, which is if others can do it, you can do it too. And if none can do it, you must do it. Shank's work has been recognized by many prestigious events and institutes, including the Ellen MacArthur Foundation, James Dyson Award, Forbes, World Design Organization, Dada, Saheb, Phalke Film Festival, and many, many others. Shashank, thank you so much for joining me today.
Hi, Evan. Thank you for inviting me.
Yeah. So, Shashank, you have a very interesting journey, right? Which is you were a student at National Institute of Design. I'm just curious about how did you stumble across this problem, and also even if you can, what's the importance of this problem?
So these days, of course, we have a lot of attention towards plastic as a material, and the concern that it doesn't biodegrade and it is hindering the natural habitats and life cycles. But while I was pursuing my master's in industrial design and specializing in ceramic and glass, I realized this through an epiphany moment while I was visiting industries for our industrial visit. We saw these heaps of production rejects that were thrown on the roadside just outside the factories. And that was my epiphany moment to realize that archaeology is actually based on this fact that ceramics don't biodegrade for centuries. We excavate these ancient civilizations, these old sites, and the first thing that we get is the broken shards of pots or ceramics. And that's how then we find how old the civilization was or what the culture was. And today, industries are facing serious issues about what to do with their production rejects because production has been at its peak since past 5 decades approx, and it's ever increasing because of the high demand and affordability and the construction and modernization. And ceramic is one thing that nobody can really predict what would come outside from the firing process from the furnace. So if we get any kind of rejections, we can't really fix it to some extent. I mean, to use it as for its primary purpose, and then it just goes to landfill where nothing happens. It's just a dead weight, and not just that, it may not impact the environment per se in the landfill, but it affects the amount of energy and the natural resources that we consume to make these products. So that's how I stumbled upon this idea.
Interesting. So, ceramics, as a consumer, if I'm choosing, let's say, for a plastic mug, I would be more inclined to pick up a ceramic mug, and just because it has some benefits, right? That it's sturdy, uh, it of course can break, but it can, let's say, hold your drink warmer for a much longer time, uh, and it can withstand a lot of forces. But yeah, I never thought of say what is the reject rate which is there in production, because you have so many ceramic companies, and ceramics it covers a broad area, right? Not just I guess consumable products like coffee mugs and the likes, but even tiles and sanitary ware and whatnot,
Yes.
right? What is the reject rate in those sort of industries?
So officially it might be around 5%, but practically it comes to around 20 to 30%, considering the primary grade A products.
And this is just in India, or is that the global rate?
It could be globally. I mean, it will depend on how optimized the industries are, but it's very difficult to predict. So it's such a natural process and material that you can't really predict.
Okay, and there is absolutely no fixing. So let's say if there's any rejected product or some or a quality deficient product, it is just sent to landfill. It can't be broken down any further for it to be used.
As of now, no, and that's what we are working on. And even as consumers, if you see, if you have anything ceramic that is broken at your home or workplace, nobody is ready to accept it. Glass, paper, wood, metal, all these things are easily accepted by these vendors who collect scrap, but ceramic is not accepted.
That is true. Actually, as we speak, I'm getting some interior work done at my home, and we try to recycle as much as possible, and even working with scrap vendors, and no one was ready to take any ceramic product, like none at all. Even in terms of, hey, it's completely great, you can reuse it. Is that more of a stigma thing, or is that a limitation of the product itself?
Both. So in the Indian cultural context, we prefer not to keep anything that is cracked in our home. So that's of course a cultural belief. And technically, right now there has not been uh, a solution that we can replicate at a larger scale. We of course use these broken shards to make mosaics and various kinds of art pieces, but probably to implement it at larger scale, at an industrial scale, we don't have much solutions as of now.
So now coming back to how you started your product, like what inspired you that this is the area I can look at, and how did you go from that as a problem that here there's all this ceramic waste which is sitting in landfills, and so that's the starting point, and then you hitting upon this is the product which I'll introduce.
Yes. So before going to that point, I just want to highlight the benefits of ceramics, because every material has its own benefit. And even if we have metal or plastic tableware or any other kinds of product that can replace ceramics, but one benefit that we know for ceramics is that it's used where we definitely need hygiene, whether it's washrooms, any kind of sanitary ware products, or our utensils in which we eat. We need a lot of hygiene there, and ceramic has this layer of glaze over it, which is actually a layer of glass. So glass, we know, is one of the most inert materials in the world, and it's very easy to clean glass. So that's why it's very beneficial to use ceramics, and also it's very microwave friendly. Even if we have these microwave friendly grade plastic, but studies have suggested that if we heat plastic, or even if we just keep hot edibles in any plastic container, the plastic would start leaching, how much ever good quality container it is. So that's why it's very necessary and beneficial for us to use ceramics in our life. So I mean, it's not that just because we are working with this material we need to keep continuing, but there is definite application for each material.
True.
So this is something that we need to highlight, because of course we know that plastics is cheaper and doesn't break, but then there's a lot of harmful impact on our health through it. Yeah. So coming to our point, you were saying
No,
something.
I just like, okay, so yeah, I'm curious about your journey from finding that problem to landing upon your product.
Yes. So again, as I was saying, I have been working a lot on different materials. So since my undergraduation, I have been exploring a lot of different materials for various applications. So I did animation for my undergraduation, and even for animation, I specialized in stop motion animation, where we make these miniature sets and move them frame by frame to make a whole film or short film. So in that as well, I explored different materials, and I did a lot of explorations in terms of making different products. But I have worked extensively with paper as an art form. And with paper, what happened was I could not use the things that I made because paper didn't offer much durability. So that was something that kept pinching me, that I'm not able to use these things. So that's why I thought a ceramic would be a good avenue to explore for my masters as a new material, so that I can make something with my hands, glaze it and fire it, and it will be a ready to use product. And fortunately, I got admission at NID. And then while I was pursuing the course, I realized that so as designers overall across as a community, we make a lot of iterations of existing products. We try to add value through different kinds of surface finishes, aesthetics, or even ergonomics. But at the end, it's still very subjective. You can't really suffice each need or even make people happy with different kinds of aesthetics. It's so subjective, and it has to keep changing from trend to trend or season to season. We have to come up with different collections, and it just keeps adding to the clutter in the market, and then eventually there's a lot of wastage as well. So I thought, why not make something that is objectively meaningful for all of us, and then probably continue doing what we are doing in terms of innovating and being creative about it. So that's how I kept tinkering my mind about these concepts and how do I really add value as an individual, as a designer, or even a professional. And then it so happened that we visited this industrial cluster of ceramic production for our industrial visit. And then I found all this waste. And then after 1 year of that visit, we had to start our graduation project. So then I thought, okay, instead of taking up an internship, let's start a self-initiated project and see what we can do with this plethora of waste that we have in the country, and if we can reuse it somehow. And then I started doing a lot of tests as a part of my graduation project, and that's how this project began.
So that's the part I'm curious about even more. If you don't mind, let's dig that further. So you saw a lot of, uh, well, you stumbled upon the importance of ceramic as a material to explore. And then
Yes.
I guess luckily you went to this industrial visit where you learned a bit more about the process, where you saw a bunch of waste. What kind of product were you looking at that time? Was it tiles? Was it crockery? Like what did you start with first?
Yes, so I started purely with a material. So I wanted to make a universal material which can be used to make any existing ceramic products.
Great. So that's your I guess your end point, right? That you want to get there. Now, what was the source of that? You looked at, I guess, the waste that these companies were producing, and from there, how did you land upon that? I think I have something here.
So there are a couple of kinds of waste as well in the ceramic industry. First is, of course, the production rejects, the glazed pieces. Second is the plaster waste, because ceramic industry most often cannot exist without these plaster of Paris molds. That's what we use, and these molds have a very limited lifespan of number of casts that we can get from each mold. After that, it's just a bunch of material that is lying there. So that's another kind of waste. And then another is a glaze waste. So out of all these three, I thought it would be much beneficial to work on the core material itself, the glazed pieces. And so then I visited one of the ceramic manufacturing clusters in Gujarat to do my primary research and interact with stakeholders at what the situation really is, and what all is possible and what all is available already and what's being done. So I got to know that that's an interesting story that I get to know from my seniors and mentors, that 10 years back, if we would visit this cluster by road, 10 kilometers before reaching the town, we would see sanitary ware waste just thrown on either side of the road. That much rejections we had as a cluster of industry. Now, of course, since past couple of years, the pollution control board has started getting stricter, so they can't throw away the waste outside their premise. So the town is pretty much cleaned out, but the whole waste is just being hoarded within the premises of these industries behind the walls.
Wow. So it's just not seen, it's not visible.
Yeah, exactly.
Okay, so you show up there, you say, I want to do something with this waste. Were they welcoming you with open arms, or were they looking at you with skepticism?
Both. That depends from what level of insights they had or what kind of openness they had. But one good thing that I found is that so there are two differences here as well. One is the unorganized sector, one is the organized sector. So the unorganized sector as well is using this waste in their production process, of course, because of the directive from the board and otherwise. That, but they are using 2 to 3% of their in their material composition. So 2 to 3% of this waste is being crushed and used as a raw material composition. So this is, of course, a good start because their scale is quite big. Each industry, I mean, on an average, these industries have a production capacity of 10 tons per day. So if they are using around 2% of it, so you can imagine how much kgs of waste is saved. So overall, one industry owner shared that in a month they are able to consume 32 tons of this waste as their raw material.
Wow. So So again, going in further into your journey, you start taking a look at this core material. So you just took some of that waste and brought it to your labs, or were you working in those factories?
I brought it to our institute and then started doing the tests. Interestingly, what insight I got is that if we make sanitary ware, if even if it has a very minor crack in it, we can't use it for its primary purpose in the primary market because it's supposed to contain water. If it starts leaking or if it holds something, it may not give us the best hygiene. So a sanitary ware is probably anywhere from 15 kgs to 20 kgs of weight or even more depending on the model. So just with that one crack, the whole 20 kgs of material gets wasted. And imagine there's 250 industries manufacturing 10 tons every day. So much of waste is coming out every day.
Unbelievable. So so you take that material and your so what does your process look like at a very high level?
So we pulverize this waste. Fortunately, we already have this raw material in the supply chain set because the industries are already getting it crushed. So we procure this, we mix it with our proprietary clay composition that acts as a natural binder and turn it into a slip, which is a liquid clay, which we can cast into molds. Then it is casted into molds, and now the whole process is same as the conventional manufacturing process. We cast into molds, fire the piece first time at 900 degrees Celsius. So it becomes a bisque piece. Basically, the water from the clay gets removed at a molecular level. So the clay is not dissolvable in water anymore. Once that happens, it's much easier to handle the piece. Then we glaze it and then we fire it again at 1200 degrees and then we have a finished piece ready.
And what do those finished pieces look like?
Oh, like this.
Ah,
So
beautiful.
yeah. So the idea was that one was we should be able to use maximum amount of recycled content in this process or the material, whatever we are able to develop. Second, we should be able to use it as easily as possible because during my secondary research that I was conducting initially, I get to know that uh, a lot of these green innovations are very, very impactful. But the big challenge is that you need a high investment upfront to put in new machinery and adopt technologies. And that's why the eventual finished product becomes very expensive, which should not happen with this. That was the thought. So that's why we tried to use this material in a way such that it can be used in a conventional manufacturing process, which it makes it very affordable.
So in other words, even if you were not the only one doing this, other ceramic manufacturers could adopt your approach and they could convert their waste into products of their own choice.
Yes, exactly. So that's our long-term plan as well. That now that we have the patent for this composition, we want to license out the use of this material to existing manufacturers so that they can use this material and at their scale we can have a huge impact. So imagine reducing 60% of usage of natural resources at a level of 10 tons per day. So we can save 600 kgs of materials, sorry, 6 tons of material per day per unit of manufacturing facility.
That's mind-blowing impact, Shashank. And and I guess what are the products like? So what is your I guess how are you testing the market right now?
So right now, as we speak, our test batch is, I mean, the initial batch is just getting manufactured in collaboration with an industry. We'll put it out for sale online on our e-commerce website and probably at some offline stores as well. Once we know what kind of response we are already getting a lot of inquiries from different stakeholders, the industries, the end consumers, and other brands as well. So hopefully this works out well after we launch, and then we'll scale up and start collaborating with other industries as well.
This is beautiful product, Shashank. And if you can show them to us again, like I mean,
Yeah,
they're quite colorful. I thought I'd assumed incorrectly that things made from recycled products would just be one color or something, and but here you've been able to get some good aesthetics into those also.
yeah. So just want to highlight these things. So of course we have to treat different materials differently. Now let's just take the most common case of plastic, which we already are aware about. For plastics to recycle, one major thing is that we first have to segregate it based on the grade or the different kinds of plastic that we have. Second is based on the color, which is a more tedious task as well, because by mistake, if we mix multiple colors together, it will eventually end up being brown or black, which has a very low recycling commercial value. And this actually increases the cost of the recycled material. While for our innovation, we can mix any kind of ceramic products together, get them pulverized, and we'll get a very neutral color after the bisque firing process, which allows us to have any kind of glaze over it. So you can have endless possibilities of colors and material finishes with this. So this is something of a positive feedback that we are getting from the consumers, is that aesthetically you can't make out that it's made out of recycled material or a conventionally virgin material, and that is making them more inclined to use this product, because for them it's important to know that it's made out of recycled material rather than it being visible that it's recycled.
And how strong is it compared to the, I guess, the original product?
Oh yeah, so we got this material tested at a third-party lab, and after the test, we realized that the material is actually 35% stronger than conventional ceramics. So that's also a benefit using this material.
Amazing. So you didn't expect that from when you were doing the materials design, or when you were designing your experiments to manufacture these, you didn't expect the strength benefits.
No.
That's a good good thing to stumble upon this way. Uh, and in terms of the usability, like, so all the ways that you collected, let's say you start with 1 ton of this original ceramic waste that was collected, you pulverize, and then you landed up with the finished product. Can you take that entire waste, or you also have a similar wastage which will go to landfill?
So from our process, if we are able to manage it properly, we can possibly do things at a zero waste level. Of course, it's very difficult and challenging, but in the technology allows us to achieve that. Now it's our practical challenges that probably hinder us to achieve it at this level, probably. But yes, so the idea is that, again, during my research, I got to know that there are a lot of ways to make recycled products, and a lot of people are doing it. Now, the most common thing that is being done is that, so okay, let's explore the theory of making a recycled product. Technically, it's very easy. I mean, theoretically, it's very easy. We just need a dry waste. You need a binder, mix it together, give it a shape, it becomes a recycled product. But what happens at the end of life of these products? Because if we see across the spectrum of recycled products, most often what we do is we either use plastics, resin, or cement as binders. Now, all these products, when all these binders, when mixed with any kind of waste, they might give you good performance and aesthetics and quality in terms of recycled products. But what happens at the end of life of these products? We can't separate these binders and the waste at this level, at the end of life of this recycled product, and that's why it eventually ends up in landfill again, or we just crush it down or pulverize to make aggregate again. But that doesn't add to the quality or the the properties of the material, and that is something that I struggled with for a couple of months to really find out how can we go about this, because otherwise it would have been very easy to just put these shards, beautiful different colored shards, into transparent resin and just make something out of it. But it again is a problem. We are just extending the landfilling time of that material. In fact, we are adding more material with resin and cement to the landfill in the second stage. So then eventually somehow it triggered that we can use clay itself as a binder to make these products, because clay after firing becomes ceramics. So we are essentially working with a mono material that helps us to recycle these products multiple times.
I love how you really factor in the system design, for sustainability, right? Because, like you said, we don't pay attention to how we ultimately will discard our recycled product. Like, we feel good as a consumer saying that I bought something which is made from recycled waste, right? So I'm extending the life of something. But yeah, when that purpose is not there anymore, when that product is discarded, I don't know what happens to it. I have no idea whether it can be discarded further, and it sounds like there is a big gap which exists in this industry.
Yeah. So, I mean, that also came from my experience as a consumer with all these electronics. I remember all the products that we had earlier during my childhood were all screwed together, all the parts. So we could actually separate them, replace them, or repair them. Now everything is just snap fit. We have to replace the whole product, and it just doesn't make sense. And that follows into every other kinds of materials. We fuse a lot of different materials together instead of bind screwing them, or putting them together in a way which can be detached. So there's a whole different vertical of design where we say design for disassembly.
Design for disassembly.
Yeah, which allows the products to be
Yeah.
disassembled and probably to be repaired or recycled, so multiple parts to be taken separately.
This is amazing, Shashank, because the world is trying to make good progress towards sustainable development goals, and India, has a few areas where we want to do better. And I truly wish that your product will inspire many ceramic industries to go further down this path, right? Because we have such a large ceramic industry, that delivers amazing products that we all use on a daily basis. And even if a small percentage of those turn into adopters of what you have created, the impact will be immense.
Yeah, definitely. I mean, let's look forward to that. And again, so there are a couple of other points as well that we thought of in this. Uh, in ceramics or in general, in terms of these products, the secondary raw material products that we make from, we should obviously always reduce, reuse, and recycle. Now during my project, or even now, I don't have such a technical expertise to reduce the wastage at the industry level itself, to optimize their processes, and which other technical institutes have already done. So earlier, I got to know from the stakeholders that the wastage percentage at these industries was 7 to 8%. Now it has come down to 2 to 3%, the official figures, which is a great progress. Now that should definitely the goal, so that we reduce the waste in the first place itself. Now, because I could not do it, but there was already so much of waste that was already lying, so we can't do anything about that even if you optimize the current production process. So that was my goal. My goal was to reduce the consumption of natural resources. Now to consume that, we can't reuse, secondly, because broken ceramic shards are very sharp, and it's difficult to work with them. And these pieces would be broken in a very subjective way. Each piece is differently in a different shape. So how do we really come up with a system to reuse these pieces and do something about it? Now, of course, we can make a lot of art pieces or installations and other things, but how many of these are we going to do it? And again, I always have this thought that instead of holding out a waste into some kind of form, and of course it might raise awareness and have some kind of function to it, but it would be best to take this waste into its mainstream material supply chain, so that we can keep reusing it. Material should always be in the supply chain rather than keeping it in some other form, and not reuse it. So that's why we chose to recycle this material rather than reduce or use. So that was also thought of in the initial process itself. And my initial aim was to be able to implement this innovation at an industrial scale, and that is only possible if we are able to make it a objective process rather than subjectively addressing each and every broken piece. And that's why it might be a bit energy consuming at an initial stage of pulverizing, because it's an abrasive material. But this material, because it already has these glaze particles in it, while firing consumes less energy, so overall it gets balanced.
The terrific, Shashank. I think the way you and Earth Tatva are following system design, not just in making products for yourself or at a company at your nascent stage where you are, but you are thinking about the industry, you're thinking about the consumer, and importantly, you're thinking about the environment. So certainly more power to you, and I really hope that you drive up as much adoption of this as possible. Best wishes to you, and thank you so much for sharing this journey, Shashank. And
Thank
let
you.
us know how we can join your journey. Like if there are ways that we can follow, or when shall we look out for your product announcement? Just please share us with that, and I'll inform on my podcast and other channels, right, that hey, this is out for us to use.
Sure. Yeah. So we are hoping to launch probably sometime in January, the second half of January, in 2023. Again, so one more point that we are working towards in terms of raising awareness is among consumers. So we as consumers are wired to find something aesthetically pleasing only if it's a perfect replica of all other products that made in a particular batch for mass production. But if we really take inspiration from nature, nature doesn't have any replicas. Each piece is unique, like all of us. We celebrate each other's uniqueness and differences, right? So why do we have such kind of expectations in terms of mass manufactured products? Of course, I'm not saying we have to compromise on the quality, but with ceramics, what happened is clay has its own memory. So while we work with products with clay to make these products, uh, it has a very high chance that it gets deformed for various reasons. You may not get a very perfect circular shape that you see in the industrial production right now. And because of this expectation, what happens is uh, in the ceramic industry, manufacturers get a lot of pieces that are warped, which are not perfectly circular or perfectly geometric shape, but they are fully functional. They suffice their primary functional goal of containing whatever food or sanitary ware or all these things. But because they are not perfectly geometrical in terms of the aesthetic perception, these pieces are just thrown away as rejects and they are landfill. And this, our perception as consumers, is also feeding into this so much of waste. So right now, with our first collection, what we are doing is, of course, the material itself is at a nascent stage. We have to keep iterating and refining it further. But with our production, none of our pieces are perfectly circular and they have these deformations in each piece, but they give each of them their own character, but and they give you full functionality. So this is something that we want to share with our consumers and users, not just about our products but any kind of products, that if we are a little bit more empathetic about the whole process and material of what goes into making any kind of product, even if it's industrially made, we would perhaps contribute lesser towards these kind of rejections, which are just based on our perception. And funnily, I just share incident with you. I read this somewhere that even with food, there is a concept. I mean, a thing called funny foods, where these vegetables and foods which have very weird shapes and color, they are just rejected from the market and thrown away because they don't look as our conventional process. And that's happening with our products as well, which is a very disheartening thing.
But it's weird, right? How we have this expectation from anything which is mass produced versus something which is, let's say, a designer dress that you're creating. There you want it as unique as possible. In there, if a designer is making, let's say, your wedding dress, you want it to stand out from others. So you don't want it to be a replica. And as consumers, we are very particular about that. But if I'm now going to buy, let's say, an industrial product, it could be a coffee mug, it could be, like you said, a ceramic product, a sanitary ware thing. I have certain expectations about the shape. I'm not tolerant when it comes to deformities. And I think we've created this imbalance, over years. And I wonder how we can overcome that.
I mean, I just slowly by being empathetic. And one thing again that comes across my experiences is that people don't know the process of how different things are made. We only, of course, spend and buy these products through our hard-earned income, but we don't know what goes behind it, and that's why we have very low empathy about things, and we have very high expectations because of how technology is evolving quickly these days. So I think that's the big gap. We need to show a lot of behind the scenes to people across different industries to realize what really goes into doing it.
Yeah, and maybe if it's possible to even market out the unique elements of those products, right? That this product is unique to you. If it is sold that way, it creates a different level of bonding versus,
Definitely.
this is one of the many that we created, and each one of them is an exact replica of each other. So I think that expectation is also being sold that way, and maybe we need to
Maybe.
change the messaging around that.
Yeah, makes sense.
Yeah, no, very true, Shashank. I think you pointed out an important bias that we all have within ourselves, and it's quite possibly an unconscious bias for many people. And the more cognizant we get about that, the better it is going to be for the environment. Yeah. No, thanks, Shashank. Thank you for sharing this journey with us today. And I will share, all your social handles and the set of Earth Tatva on this episode. So if anyone who's interested, please follow Shashank, follow his work. He's a very passionate person who's out there to make our world a better place. So thank you again, Shashank.
Thank you so much. Have a good day.